Okay, so let's look at the greatest common factor. When we're asked to factor, this is always the very first thing we look at. Is there something common between the two terms or the three terms or the four terms that are in front of us? Okay, so I've got four different options for us to look for a greatest common factor. The first one here, 8 and 6. Now, how do we find what the greatest thing that they have in common? Often in the past, you've written a factor tree, and we can do that. 4 times 2 is 8. 4 can be factored as 2 and 2. So these are the factors, then, of 8. And similarly, we do that with 6. We see the factors are 3 and 2. And the factors, then, are written there. And so when we look for the greatest common factor, what do these ones have in common? I see only a 2 that's common. So in this case, the greatest common factor would be 2. And we could factor out a 2 out of 8 and a 2 out of 6. Let's look at the second set. What do these have in common? Now, we don't see any numbers, we see variables, but we also look for common variables. So when I look at this, grab my highlighter again, I see the only thing in common here is Z, right? And so we would write here that the greatest common factor out of these pairs is Z. Let's look at the third example here. Now we see numbers and variables in this, and we can see right off the bat that the variables they have in common are an M. Okay, 1M. And what about numbers? What's the greatest common factor with the coefficient of each of these terms? The coefficient refers to the number in front of the variables. And we could write a factor tree. I can see that here the lowest factor is 2. And here, if I wanted to factor that out, it would be 2 times 2 times 2 times 2 gives you 16. So we have a common 2. Our greatest common factor then of these two terms is 2M. Lastly, if we look at this, we also have coefficients and variables. And the coefficients, I can see the lowest common factor between 3 and 9 would be 3. And again, you can write a factor tree and figure that out just like we did with the first example. So we have a common 3. Now what about variables? In this first term, we have 2 x's. We could write that as x times x. We know what that's what x squared means. And in the second term, we have 1x. So we have 1x in common. They share 1x, and we have an extra 1 in the first one. So our greatest common factor would be 3x. Okay, let's apply this to an expression. Okay, here's 2 expressions for us to look at, and it says the instruction is to factor. When we factor, the very first thing we try to factor out is the greatest common factor. So looking at number 1 here, what is common to these 2 terms? Here's the first term and the second term. What do they have in common? Okay, so let's look at the coefficients. What do the 4 and the 6 have in common? Well, they're pretty low numbers. We can see that a 2 would go into them, and nothing higher than a 2. So we know that a greatest common factor will have a coefficient of 2. Now what about the variables? What's common there between these 2 pink circles? We see they both have a, right? B is not common. It is not found in both terms. So they have a common a. Now, to factor that out, we need to now know if we take a 2a away from both of these terms, what are we left with then? So we factor out a 2a. Now, if we take a 2a out of 4ab, what are we left with? 2 times what is 4? 2. So 2 times 2 would be 4. Okay, a times 1 is a, and we're left with a b. So now if I would multiply these 2 terms together, 2a times 2b, I would get 4ab. Second term now, what do we need to multiply here by our greatest common factor to get 6a? So 2 times what gives me 6? 3. and that's it. 2a times 3 gives me 6a. Another way you can think of it is take this pink circle and divide it by the 2a. So in your answer key, if you have a look, they often write, okay, my greatest common factor is 2a. Well, let's write down divide by 2a, because that sometimes makes it easier. And then if I think of 4ab divided by 2a, I'd be left 4 divided by 2, a divided by a, well that's 1, b divided by 1, and plus 6 divided by 2, a divided by a, would give me this. So you can think of it that way as well. Let's look at number 2. Greatest common factor here. Now it looks daunting with all these exponents, all the different variables, coefficients thrown in, and negative thrown in. But still, we go one at a time, looking at the coefficients and then looking at each variable to see what these two terms have in common. So if we look at the coefficients, 15 and negative 10, they have a common 5. 5 goes into both of those numbers. All right, now let's look at the t's. This first term has 4 t's. This is t times t times t times t. The second term has 2 t's, t times t. Well, how many do they have in common? Well, they have 2 t's in common. And now let's look at the z's, or the z's. The first term has a 1. Remember, if there's not an exponent, we assume it's a 1. And the second term has 3. So together they have 1 z in common. Now, if we're going to factor out that greatest common factor, we need to know what we're left with. So inside the brackets is going to be what we're left with. Now, let's picture in our minds, if I would take this first term and divide it by the greatest common factor, what's left? Divided by 5t squared z. I just dragged that down a little bit to make some space. Okay, so let's picture this. Now you don't necessarily need to write this red down, but that's what's going through your mind. That's what you're thinking. 15 divided by 5 gives me 3. T to the power of 4 divided by t to the power of 2. Well, if you remember from the past, we subtract exponents when we're dividing. So if you think we have 4 here, we divide those by 2, we're left with 2. We subtract the exponents. And z to the power of 1 divided by z to the power of 1. Well, anything divided by itself is 1, so that cancels out. Let's do the same reasoning now for the second term. Divide it by our greatest common factor. And negative 10 divided by 5, we'll be left with negative 2. This is going to cancel, it's the same. Here, we've got z to the 1. When we divide exponents, we subtract them. So we're going to have z to the power of 2 left over. Now, let's see if that makes sense. If I would multiply this back through, so if I would distribute this, multiply this times this, and then this times this. Let's see if we get our original. So, 5 times 3 is 15. T squared times t squared. When we multiply with exponents, we add them. Z times 1 gives me a z. 5 times negative 2 is negative 10. T squared times 1 is t squared. Z times z squared is 3z, which is correct. So any of these equations, or expressions, you can check by multiplying them back through. Okay, that's using the greatest common factor to factor. You can move on to your assignment.